Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which finds the maximum and minimum element in a binary tree. First, let us see an example. As you can see, in this example, the maximum element in the tree is 11 and the minimum is 1. Now, let us see the algorithm which will assist us in finding the maximum element in a binary tree. Let us also have a sample tree to test our algorithm. We pass the root node, which is 1, into the findMax function. So, root will point to 1. In the next step, we check if root is null. Since it is not, we continue. We have another variable res to store root's data. So, res will be equal to 1. Now, we recursively call the left and right subtree of root 1 using a call stack. We pass the left child of node 1, which is 2, into the call stack. We check if root is null. Since it is not, we store root's data into res. So, res will be equal to 2. Now, we pass the left child of 2, which is 4, into the call stack. So, root will point to 4. Also, since root is not null, variable res will store root's data. So, res will be equal to 4. Now, we pass the left child of 4, which is null. Since root is pointing to null, we return the minimum integer to lres. We continue execution for node 4. Now, we pass the right child of node 4, which is also null. Since root is pointing to null, we again return the int min to our res. Now, we compare the data of lres and rres and return the max of 2. Since both are equal, we just return res. So, 4 is returned. Now, lres will be equal to 4. We continue execution for node 2 and pass the right child of node 2, which is 5. So, root will now point to 5. We check if root is null. Since it is not, we store root's data into res. So, res will be equal to 5. Again, we call the left subtree of node 5. So, we pass null. Since root is null, we return int min. We repeat the same for right child of 5, which is also null. Now we compare rres and lres. Since both are equal, we return res, which is 5. We continue execution for node 2. Now we compare lres and rres. Since rres, which is 5, greater than lres, we change res to rres and return res. So we return 5. We continue execution for node 1 and now call the right subtree of 1. So we pass 3, which is the right child of node 1. Since root is not null, we store root's data in res. So res will be 3. Again, we pass the left child of 3, which is null. Since root is null, we return int min. We continue for the right subtree and pass the right child of 3, which is also null. Again, since root is null, we return int min. Now we compare data for RRES and LRES. Since both are same, we return res, which is 3. We continue execution for node 1 and compare LRES and RRES for node 1. Clearly, LRES, which is 5, greater than RRES, which is 3. So we assign res as LRES. Finally, we return res, which is 5. Hence, 5 is the maximum value in this binary tree. For finding the minimum value, we follow the same method but replace the greater than sign with the less than sign. As you can see, this code returns the minimum value in a given binary tree. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in our binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.